Okay, so welcome to the first ever webinar, right, from Mr. Chua. Right, so for those of you who are keen, this is actually the science web. We are basically focusing on water cycle related questions, right? Water cycle related questions. Right, so let us start off with the first question on page 86 of the PSLE book. Right, a fairly typical question. A worker used a truck to deliver blocks of ice. A mist was seen when the ice was taken out of the truck, as shown. So that's a phenomenon that we have seen quite often. So what's happening here? Explain how the mist was formed. Now, from the perspective of answering science question, I always advise all students to look at the number of marks. The 2 marks question tell us that there are probably 2 to 3 critical and important points. So what are the 2 to 3 critical important points? When we go back to the question again, we realize that this is called mist. And from mist, we actually generally should have 2 main ideas. 1, is it water vapor? 2, is it water droplets? So that's the clarity that we must have before we can even answer this question, right? Then how do we judge if it's water vapor or water droplets? We always say vapor is a gas and vapor you cannot see. So typically in layman terms, this is how we remember. And droplets is liquid and droplets are things that we can see. So we have from droplets, liquid to gas that we cannot see. And this generally will be the whole idea. Next, based on the 2 points, how then do we talk about mist? Based on the 2 points here. Okay, explain how the mist was formed. In this particular topic on cycles, we also want to always talk about this important concept of from where to where. Okay, from where to where. Now, in the phrasing of an answer, this is critical because we must recognize that a cycle starts from point A, loops to point B, loops to point C, and then finally go back to A. So it's an ever revolving cycle, meaning it never ends. There's no starting point, there's no ending point. Every starting point can come to the next ending point. And that's the whole idea of cycles. So first, identify whether the mist is water vapor or water droplets. So can we see or can we not see?
See.
See. So if we can see, we know that it must be water droplets. Okay. Then how do we construct our thinking behind it? From can see, from something to can see, that means it must come from something that cannot see. All right. So how was the vapor formed? We have to ask ourselves, are the vapors coming from inside or outside the truck? Inside or outside the truck? Okay, so obviously the mist is outside the truck. That's another important idea because we spoke about from where to where, right? And with all these ideas in mind, we can then now know that mist are formed must be from cannot see to can see. So how are the mist formed? The warm water vapor from surrounding air. So the warm vapor from the surrounding air undergoes a process known as condensation, condenses as it comes in contact with the cooler air from the truck. Okay, so the warm water vapor, and the water vapor did not come from the inside of the truck, but from the surrounding air. It undergoes a particular process known as condensation. All right, and then when it condenses, comes in contact with the cooler air, condenses, and form water droplets, which is in this case the mist. So earlier we spoke about 2 points. What then are the 2 points? All right, what then are the 2 points? Point number 1 is of course the process. Process is very important. Condensation. Point number 2, what changed to what? Can you see that? From what to what? From water vapor to water droplets. From water vapor to water droplets. So that's the second important point. Now the third important point comes with this. When we want to talk about condensation, we must always talk about this. Coming in contact with what? So in this case, there's no surface. In most questions, there is a surface in which the hot water vapor can come in contact with. But in this case, the mist is formed because there is cool air. All right? So this means to say that the concept of condensation, when you talk about cooling, you either have a cooler surface, and I'm going to show you another question relating to cooler surface after this, or it comes in contact with the cooler air. So this is also an important point. Okay, so basically this is how you answer this question. Pretty much whatever I have mentioned before in class. And let me reread the question one more time. The warm water vapor from where? From the outside of the truck, from the surrounding air, undergoes this process called condensation. And then it comes in contact with the cooler air from the truck, and then water droplets are formed. Now the mist disappeared after a short time. Explain why. Now when the mist disappears, there are a few possibilities, right?
Gain heat.
It gain heat and evaporate. So the mist could have gained heat and evaporate into water vapor. Which basically means that the opposite process occurs. So just now it was cannot see, condenses into water droplets that you can see. Now it's can see, gain heat, and then evaporates into something that you cannot see. Okay, so that's one possibility. Now, what is the other possibility in this question? Right, what is the other possibility? So I'm going to change screen into the whiteboard. Right, so I'm going to change screen to the whiteboard and talk a little bit about this idea of condensation. Those of you who with paper, you may want to take down some notes, okay, because these are ideas and concept behind condensation. Okay, so if you have paper, let's take some notes. Now, what's the whole concept of condensation? Condensation is a process in which the water vapor becomes water droplets. Now, so one very interesting example that happens all the time is we have ice cubes in water and there are water droplets here. So these are water droplets. And all these are a consequence of condensation. Now, this is before. If this is before, we wait for the ice to melt. Then we leave beaker in the room for, let's say, 1 hour. What's going to happen to the after? What's going to happen to after? We're going to have a beaker and we're going to have water, most probably slightly more. And if we realize that all this thing disappear, so the droplets will disappear. So this is condensation, the droplets disappear. Now, when the droplets disappear, what does it mean? What does it mean? Now, we can see the droplets disappearing from two perspectives. That means two ideas. One, the water droplets that are on the beaker evaporate into water vapor and returns to the air again. The other way of looking at it, which may apply to some possible scenarios, not all, but some, is the very fact that now the water inside is the same temperature. So the water in beaker has the same temperature. Let me rewrite this. Has the same temperature as the water droplets no, wrong. As, okay, I repeat, a bit of error here. It is not the water inside, but rather the surface. The surface temperature at the beaker is the same as the temperature of surrounding air. Now, when the surface temperature is the same temperature as the surrounding air, will any more condensation take place? No, right? Because they are the same temperature. So because no condensation takes place, then we know that there will be no more water droplets that will be formed on the surface. Okay? So for those of you who are not so sure, you may want to ask some question. If not, you may want to take down some notes here. So the before and after for condensation concept is pretty important. Are we all quite all right? Is there anybody who has some question to ask or would like to clarify or are taking some notes? Okay, so maybe we give another 30 seconds for people to write down. Right, so condensation occurs when water vapor turns into water droplets. That's why we can see the water droplets. However, in a situation where the ice melts and then the beaker starts to gain heat, we realize that the surface temperature of the beaker is now the same temperature as the surrounding air. And when that happens, condensation stops. And when condensation stops, we realize that there is no more difference in temperature and water droplets will no longer be able to form. The other way of looking at it is the water droplets are there on the surface of the beaker, but it gains heat and evaporate into water vapor again. So if you're not quite sure of these two concepts, you probably would have to spend some time to really clarify your doubts and then write out a few such sentences. And from there, we can then know very clearly which is condensation, which is evaporation. Okay, so now let's go back to the question. Now, thick plastic strips were hung at the door to prevent the ice inside the truck from melting. Explain why. So there are thick plastic sheets here. Now, if you have gone into like a freezer kind of setup in NTUC, in such trucks, you realize that there are really thick plastic strips. Okay, so once again, we go back to the number of marks. Okay, because it's quite important to know how much to write is 1 mark. So it is to prevent the ice from melting. So we ask ourselves, if ice melts, then ice will need something in order for it to melt, right? What is critical to make the ice melt? Heat. Okay, so since we have already identified heat, 1 word, 1 mark, we know that the whole idea is to prevent heat from where? From the surrounding air to enter the so-called fridge or freezer. Okay, so notice that they use the word thick. If it's thin, it probably cannot prevent so much, but it's very thick. And we have identified the word heat. We already know the concept. So how then do we craft all this? Okay, so we can start the thick plastic strips.
Isn't this the question about absorb heat and no need to absorb heat?
Nothing to do with absorbing. Okay, so they just prevent. They just prevent, not absorb. The plastic strips. The plastic strips do not absorb. Okay, they are not cloth. They prevent heat from where? From the surrounding air, from entering the truck. Okay, so the thick plastic strips, when it prevents heat from entering, it means that there will be less heat in the truck, and so the ice melts what? Slowly. So when the ice melts slowly, that's the whole idea. The ice will not turn into water. Okay? So notice that in the first part, we identify condensation as an important part to write about. We identify what thing, water vapor, change into what thing, water droplets. In the second question, when it disappears, we also identify an important idea, which is evaporation. And in the third question, we identify heat as an important part to the answer. Okay, so each particular question or each mark has one particular important idea. Now, those of you in my science class, these are more or less the words that you have to use. Don't use any other words such as change. All right, if not, I would have used them in my explanation. All right, so such words must be used, okay, minimally. So if you find that you are not scoring, that's because most of the time you're not even using all these words. Okay, so how to award you the marks? All right, so that's page 86. The question on evaporation and condensation. Now we move on to one more question. Maybe let's look at this first. Right. Mary has a pot of water with a layer of oil. So we know that oil floats on top of the water. Now, based on what you can observe, realize that when I read, I want to be able to identify the important words. Observe. State a physical property of oil. Okay, so it must be a physical property. This is last year's PSLE question, if I didn't remember wrongly. Okay, 219. Okay. Now, Mary then put the pot in the refrigerator, which has a temperature of 4 degrees Celsius. And after a while, the oil froze, but the water didn't freeze because we know that water freezes at 0 degrees Celsius, but the oil froze. So is that okay? Yes, because not all substance froze or freezes at 0 degrees Celsius. Okay, so state what freezing means. And what can you tell about the melting point of oil? So let me give you 5 minutes, okay, to craft out your answers for this question, regardless of whether you have the book or not. So let me give you 5 minutes, okay, from now.
Which question?
This
A,
particular
B.
question. Every part.
Okay.
So after 5 minutes, I will then go through the answers for this question again.
I'm going under, and this time I fear there's no one to save me. This all or nothing really got a way of driving me crazy. I need somebody to heal, somebody to know, somebody to have, somebody to hold. It's easy to say, but it's never the same. I guess I kinda like the way, and I'm not a pain. Now the day bleeds into nightfall, and you're not here to get me through it all. I let my guard down, and then you pulled around. I was getting kinda used to being someone you loved, and I tend to close my eyes when it hurts. Sometimes I fall into your arms. I'll be safe in your sound till I come back around. But now the day bleeds into nightfall, and you're not here to get me through it all. I let my guard down, and then you pulled around. I was getting kinda used to being someone you loved, but now the day bleeds into nightfall, and you're not here to get me through it all. I let my guard down, and then you pulled around. I was getting kinda used to being someone you love. Can I tell you something just between you and me? When I hear your voice, I know I'm finally free. Every single word is perfect as it can be. I need you here with me. When you lift me up, I know that I'll never fall. I can't speak to you by saying nothing at all. Every single time I find it harder to breathe, 'cause I need you here with me every day. You're saying the words that I want you to say. There's a pain in my heart and it won't go away. Now I know I'm falling in deep. I need you here with me. I think I see your face in every place that I go. I try to hide it, but I know that it's gonna show. Every single night I find it harder to sleep, 'cause I need you here with me every day. You're saying the words that I want you to say. There's a pain in my heart and it won't go away. Now I know I'm falling in deep. I need you here with me. Can I tell you something just between you and me? When I hear your voice, I know I'm finally free. Every single word is perfect as it can be. I need you here with me. I'm gonna take my horse to the old town road. I'm gonna ride till I can't no more. I'm gonna take my horse to the old town road. I'm gonna ride till I can't no more. I got the horses in the back, those tackies attached. That is my black, got the boots that's black to match. Riding on a horse, yeah, you can whip your Porsche. I've been in the valley, you ain't been about the Porsche. Now can nobody tell me nothing. You can't tell me nothing. Can nobody tell me nothing. You can't tell me nothing.
Okay, I'm back. Let us continue. Based on what you can observe. Now, we cannot tell if our answer has, your answer has to do with like oil is has lower melting point or higher melting point. Okay, so we want to be able to observe. It must be a physical property. And one very important or easy answer is oil floats on water. Now, if you have learned density and your answer is oil has lower density than water, it's also okay. If we say oil is lighter than water, is this okay? It is also okay. Okay, because this is what we can observe. This is what we can observe. Okay, is there anyone who would like to
How
give
about
me
oil is waterproof?
Say again.
Oil is waterproof.
Oil is waterproof. Can we observe that? Waterproof. That's not something that it's quite clear, isn't it?
Yeah, but
Right.
if it is waterproof, it would the water would mix with the oil.
Yeah, so what's the physical property? It's not waterproof, isn't it? Lighter than water, no? Number 3. Okay, so look at the question again. You want to talk about things that you can observe. Are we able to observe waterproof? And if we say oil does not mix with water, is that a physical property? Okay, so something along this line about density, about it being lighter, about oil being able to float. Mary put the pot in the refrigerator and then realized that the oil froze. State what freezing means. Freezing
when a liquid loses heat and
refers to a change in state. So freezing is a process which involves a change in state of a substance. Okay, so this change in state is very important. A change in state of the substance. And remember what I spoke about in the previous question? It is part of cycle. So you must say from what? From liquid to solid.
How about losing heat?
Okay, so if you have loose heat, you can add in. But the critical thing, remember, is 1 mark. So if it's 1 mark, what is the important mark? You must talk about change of state. All right, because from liquid to solid is a change of state. We must also talk about how it changed state. From what to what? From liquid to solid. Okay, if oil turns into solid, but water doesn't, what does it tell us about melting point? Now, if I were to draw this as like a thermometer, where this is 100 degrees Celsius and this is 0 degrees.
Is it like your hot dog? Your hot dog 3.
Yes. So over here, there are 2 terminologies. I either call this the melting point. If not, the exact same name for this 0 degrees Celsius for water is called the freezing point. All right, so I'm referring to water. All right. Whereas at 100 degrees Celsius, there's only one name to it, boiling point. Okay, so what can we tell about the melting point of the oil? We can tell that the melting point of oil is higher. Okay, the melting point must be higher than that of water. Right, so over here at 4 degrees Celsius, the oil has already turned into solid. So the melting point must be higher. Okay, but is it at 4 degrees Celsius? We don't know. Okay, we don't know. We only know that at 4 degrees Celsius, the oil has turned into solid. Can the oil turn into solid at 5 degrees Celsius? Possible? Yes, right? Possible. But can the oil turn into solid at 3 degrees Celsius? Cannot, because at 4 degrees Celsius is already solid. So the melting point must be higher than 4 degrees Celsius. Okay, must be higher than 4 degrees Celsius. Okay, so that's this question. Okay, you notice that actually quite easy, right? Okay, quite easy to answer ESLE question. Okay, now if not, we're going to look at the last question of this segment. This, I think this was 2018 or 2019, sorry. So this was last year's PSLE question. Okay, and this was probably an example I spoke about whenever I start teaching water. Okay, and we have explained a little bit in the previous question. So same thing, I would like to give you 5 minutes to write down and pen down the answer for this part A and part B. Notice that it's 2 marks. So 2 points here, and this 1 mark. All right, so for those of you who are finding this question, this is your PSLE book, page 93. Page 93 of your PSLE book. And the question is here. I would like you to first annotate on the question stem, all right, the part A, part B, as well as to read it carefully. Okay, box up, underline, annotate on the important words. 5 minutes, and that will be the next question, okay, of the first segment. 5 minutes.
Riding on a tractor, lean all in my blood. Cheated on my baby, you can call it ice cut. My life is a movie, but hiding in movies. Got way up from Gucci, Wrangler on my booty. Can't nobody tell me nothing. Can't tell me nothing. Can't nobody tell me nothing. You can't tell me nothing. I'm gonna take my horse to the old town road. I'm gonna ride till I can't no more. I'm gonna take my horse to the old town road. Gonna ride till I can't no more. Life down cross town, living like a rock star. Spend a lot of money on my brand new guitar. Baby's got a habit, diamond rings and Fendi sports bras. Riding down the day, I'm in my sports car. Got no stress, I've been through all that. I'm all romance, so I can't come back. Wish I could roll on back to that old town road. I wanna ride. I'm gonna take my horse to the old town road. I'm gonna ride till I can't no more. I'm gonna take my horse to the old town road. Gonna ride till I can't no more. I love it when you call me a señorita. I wish I could pretend I didn't need ya, but every touch is your love. It's your love. Oh, I should be running. Oh, you can be coming for you. Out in Miami, the hours up for summer was different of me. Before I even knew her name, la la la. Feel like a la la la, yeah, no. Sapphire moonlight, we danced for hours in the sun, tequila sunrise. Her body feel right in my hands, la la la. It feel like a la la la, yeah. I love it when you call me señorita. I wish I could pretend I didn't need ya, but every touch is your love. It's true love. Oh, I should be running. Oh, you know I love it when you call me señorita. I wish it wasn't so dumb hard to it. But every touch is true love. It's true love. Ooh, I should be running. Ooh, you can't be coming for you. I think I'll hold them. There's just some things that never should. You're always just friends. Close friends don't know the way you taste. La la la. Cause it knows me a long time coming, doesn't let me fall. The way you listen, trust me, hooked on your tongue. All of your kisses, belly don't stop. I love it when you call me señorita. I wish I could pretend I didn't need ya, but every touch is true love. It's true love. Oh, I should be running. Oh, you know I love it when you call me señorita. I wish it wasn't so hard to leave ya, but every touch is true love. It's true love. Oh, I should be running. Oh, you can't be coming for ya. All along I've been coming for ya. And I hope it means something to you. Call my name, I've been coming for ya. Coming for ya. Oh yeah. Oh, she love it when I come. Oh yeah. Oh, I should be running. Oh, you can be coming for ya.
Okay, I'm back. Okay, let's take a look at this question again now. How many of you noticed that the question is very similar to the previous one?
Oh, like the truck that one, the ice cube that one.
Yep. Is it? Okay, so I think it's really similar, except that previously I was talking to you about surface, right? So let me go back to this. Let me go back to the previous question. Let me take a look at the annotation at the side. Okay, the one on the ice cube. Okay, so which part of this image here do you see what we need to use? Okay, so basically, you realize that the answer is almost exactly the same as part A's answer. All right, it's almost exactly the same. The only difference that we need to change now is between here, number 1, cooler surface and cooler air. Okay, because in this question, there is no cooler surface. But let us go back to the question on page 96, right? There is some surface here. Right, so Alice and Beatrice were traveling in an air-conned car. Both were wearing the same type of spectacles. Why same type very important?
To ensure fair experiment.
Okay, so once you see the word same, we know that it must have to do with the idea of a fair test. All right, so same type. Now Alice then put her hands over her spectacles, but Beatrice did not. Okay, so Alice cupped the spectacle with her hands. Now when they step out of the car, there is less fogging on Alice's spectacles than Beatrice. So explain why there is less fogging. Okay, less fogging. Now we see that the fog is another idea of mist. And the mist is another idea of water droplets. Right? So the mist is another idea of water droplets. So we also recognize that this has to do with condensation. So now the question is, can we just copy the entire answer from the previous question? Yeah. Cannot. Okay, because they ask you why there is lesser fogging. The question did not ask you, hey, how come Beatrice's spectacle will have fog? So the question asks for lesser fogging. So now we need to compare this. Lesser fogging means lower rate of condensation. Okay, lesser fogging, and that's for Alice, lesser. So lesser fogging, lesser rate of condensation, and that has to do with the idea I spoke about. If the temperature is the same, there will be almost no condensation, but now the temperature is lesser. Okay? Now then we go back to the question again and analyze. What are the things we can use? So we read again. Both were wearing the same type of spectacles. Alice put her hands over the spectacles. Beatrice did not. So what do we observe? We observe that Alice covers spectacle and Beatrice doesn't. If Beatrice doesn't, then what can we link the idea to? Alice spectacle must be cooler or warmer. Must be warmer, right? Beatrice spectacle must be cooler, isn't it? And cover it must be warmer. All right. So finally, what can we conclude? That this causes a difference in the temperature. Okay, so why was there? So point number one, we want to talk about covering and it being warmer or cooler. So we can start. Alice covered her specs and hence her spectacle is warmer than Beatrice. So when the spectacle is warmer, 2 marks, right? So that's your first mark. Second mark, when it's warmer, what does it mean? Warmer means what? And this is the important thing. This one we can copy from the previous question. Warmer means there is lesser water vapor will condense on the warmer spectacle to form, yes, to form water droplets is important, but less fogging means what? Means to form less water droplets. Okay, so this second part of the answer is exactly the same, but we have to be mindful to add in the word lesser because the question asks you why less fogging. So from the question stem, we will get hint of what are the words to use in the answer. Okay, from the question, we usually will be able to get our first mark. Okay, which is linking, to link what you observe to the idea behind it. Okay, so those people in my class, a lot of times you will probably write half the answer. All right, so to take note, 2 marks. Usually the first mark comes from the question and explaining what's in the question. Second mark comes from the scientific concept, which in this case is about lesser water vapor condensing on the warmer spectacles to form less water droplets. Okay, next question. Explain why the spectacles become clear again after some times. So this is what I meant. 2 possibilities. 1, evaporation occurs. 2, the spectacle has the same temperature difference as that of the surrounding air, and hence water droplets can no longer be formed again.
So this one can write the same thing.
So you realize the same thing, right? So we can use the exact same words. If I can try to remember the water droplets in heat
from surrounding air
okay, from surrounding air
and evaporated.
and evaporated. Okay. So that's the reason why I wanted to show you these 2 questions, because they look very, very similar. You can use almost the same answer. However, we must be very mindful. Each question has a context and we want to link the answer to the context. Okay, so we must read very carefully. My answer sheet or my answer booklet, if it's exam, will probably look like this. Okay, maybe less the parts on the left-hand side. Okay, but I will be circling, I will be drawing arrows, I'll be writing keywords, I'll be boxing things up, so that as I check, as I do, I know that I've mentioned all the important points. Okay, so that's a very important thing to take note of. Okay, with that, we have come to the first part of this water cycle. We're going to take a 15 minutes break. Okay, so let me just say this to Rehan first. Okay, so we're going to take a 15 minutes break now. Now it's 2:25. 15 minutes is 2:40. Okay, you can stay here and listen to the music, but I will be offline, right? Once we come back, we will continue on water cycle, but we will be doing questions in MCQ that is related to water cycle. So in this 10-15 minutes, if you are free, you may want to spend some time to look through the MCQ questions relating to water and water cycle. If not, see you in 15 minutes time.
We couldn't turn around.
Chemistry duo. We couldn't turn